Another video on the mk5 pfc2. So I learned a few more things about this. Start here with these optic isolators. So the top one is U4, and if that is lit up by the secondary side, that indicates a failure. And then the next one down is U5, which signal is also coming back from the secondary side. That's the feedback for the 24 volts, so that should be lit up. And then the last one is U6, which is the signal going to the secondary side, which just lit means good, and that just tells the secondary side that the 400 volts is up and ready to go. Okay, how about this little capacitor next? So what that does, that's a filter capacitor for the DC copy analog of the AC line voltage, which comes in on this top rail up here. So on the board, that would be right here. That comes down and it goes to several resistors, finally hitting Q11 right there. Q11 is actually wired as a diode. Not sure why they're using a transistor, but it's wired as a diode. So it acts as a rectifier, which converts that low voltage copy signal. This filters it, and then that goes into pin 9 of the LM339 for comparison. Looking at those pins, I've got that set up so on my notes here you can see what each pin does. Pin 1 is the 400 volt monitor, plus equals pass. Pin 2 is the output for U6, lit equals pass. Pin 3 is chip power, usually about 13.6 volts if everything's working correctly. Pin 4 and 5 are the comparators for pin 1. You'll see that one of those is a reference voltage and the other one is actually coming from the 400 volt rail, dropped through a bunch of resistors. Pin 6, same thing, 400 volts coming from a bunch of resistors, drop down. It's already DC, so it just needs to be dropped in voltage for this chip to compare it. And then pin 7 is kind of interesting. Pin 7 is pushed or gets its signal from a pull-up resistor, 10 kilo ohms to VCC, so 13 plus 13.6 volts through a 10K resistor. But I have a note on here that U4 can ground it out. If you remember that U4 is the signal coming back from the secondary side. So if anything on the secondary side fails, then U4 gets lit and it grounds this signal out on pin 7, which would otherwise be positive. Okay, pin 8 and 9 are the AC line check. We already talked about that. So it goes through that Q11 and that capacitor down there and gets filtered to a low voltage DC copy of the AC line voltage. Thusly, if the AC line voltage goes up, that voltage goes up. If it goes down, that voltage goes down. Okay, 9 and 10 are another compare set. Again, U4 and the 10K resistor is exactly the same thing as pin 7, actually. So U4 can ground that signal out. And then on pin 12 is the ground for the chip. And then pin 13 is the actual final output of this thing. Let's talk about pin 14 first, though. That's the AC OK. So if you're seeing positive on that line on pin 14, that's a good thing. Now back to 13. 13 is like the summation of all of the safety checks. And what you're looking for here is not ground. If this thing is a ground signal on pin 13, that's the CPU kill line. And the CPU is the UCC Texas Instruments guy here. There's no such thing as a CPU kill line. This isn't really a CPU anyway, just call it that. It's the main processor of the system. And on pin 3 of this, there's something called vSense, and it needs to see a positive voltage of around 2.2 volts or higher to enable this chip. So if pin 3 of said chip, vSense, gets grounded out, I call that a kill. And what will ground that out is any safety fail. Okay, then on pin 7